Hi, now we'll discuss valve sizing using the Fisher Specification Manager software. So this is the valve sizing window. So in this we have to enter the process data, that is sizing inputs, that is a process data. What is a liquid, what is a flow rate, what is the inlet pressure, what is the pressure differential, all these things we have to fill. Minimum these 4 items we have to fill. So based on the units. So units also you can change if you want. You have options also. You can have an option of the fluid flow rates, whether it is a mass or volumetric flow rate. Now we'll keep it as volume only. Now we'll have the units also. Units we can keep it GPM only, gallons per minute. US will keep it as it is. So this is a PSIG. You can select as you like, as per your project requirements. You can select a pressure differential also will have a different units, and temperature also we have options. And this upstream size and downstream size, we got it from the installation data where we have entered the piping requirements. That is copied here, and based on the piping data and the valve size, pipe size, so it has calculated the FT and FI, recovery factor and volume factor. These are all internals. So now we have to enter the liquid, which type of liquid if you want to enter. We have a for minimum conditions, normal conditions, maximum conditions. So sometimes we will have a liquid or fluid changing from one phase to another. So we'll have options for each unit. So we'll have because this is universal software, all types of fluids, hydrocarbon as well as petrochemical is included here. So whatever you want you can select here. Normal also you have to select the fluid, maximum also you have to select the fluid. But here now for our application we will select water as a fluid. So this is a water. I have selected the water. So when you select the water, all the water data has been taken from the lookup tables in the software. So this is a volumetric flow rate. We have to enter the flow. So minimum conditions, as we discussed in the previous slide, maybe we will select 100. The inlet pressure will keep it to 200. Then the differential pressure, when the volumetric flow is in minimum conditions, we will have a maximum differential, but it should be less than inlet pressure. So we'll go with the maximum 120. Differential. So inlet temperature will keep it as 140 only. So these are minimum conditions. Now for maximum conditions, we should enter a flow, maximum flow. We'll assume it is a 500 GPM. Inlet pressure will keep it constant 200, and differential when flow is maximum, that is valve is almost 90% open, so differential will comes down to less, maybe it is a 30 psi. So temperature also will keep it constant 140. Next we will go to normal conditions. Normal means between minimum and maximum conditions. So it may be 300 GPM flow. Inlet pressure will keep it constant. Differential will be in between. That is something like 60. Temperature also will keep it constant, otherwise it will become a steam, and steam treatment is different. So these are the minimum data we have to enter. Then we should go with a calculate here button. So we are solving for CV, we are calculating the CV. For piping we have entered a size and schedule also. So there is no insulation, none we have selected, and we will go with a calculation based on this. So when you press calculation, you got the flow coefficient, that is a CV. This is minimum, this is normal, this is maximum. So this is important for us, a CV calculation. So other things are at the moment not important for us. So we'll take this CV values to select the valve. So getting the CV is important. So you can add condition or delete condition, reset condition, summary, previous message. So if you got some problem, you will get some message here. So that message has to be considered. So here we have a standard fluids. If not standard fluid, you can select individual fluid in different conditions. So now with this CV, we will go and select the valve. Later we will go for a valve construction, then actuators, then other things. Finally, ISA sheet will be ready. Thank you.